Hello, today we're looking at implicit differentiation. So what is implicit differentiation? So implicit, or rather explicit differentiation is when we had our dependent variable defined in terms of our independent variable. So in other words, you had y equals some expression involving x, or f of x equals some expression involving x. So the y is on one side of the equal sign, so the dependent variable, is on one side of the equal sign, and the independent variable on the other. So in this case, in implicit differentiation, the independent and dependent variables are within the equation. So for example, we're asked to use implicit differentiation to find y prime. And here we have 5x cubed plus 3y squared equals 6. So rather than solving for y explicitly and then taking the derivative, we're going to take the derivative directly, keeping in mind that y is a function of x. So y is actually a function of x. So when we get to y, we actually have to take y prime. So I'll show you. All right. So let's take the derivative. Now we're taking the derivative across the entire equation. So both on the left-hand side and the right-hand side. So, and with respect to x. So we're doing everything with respect to x. So the first term becomes 15x squared. Now, the second term, 3y squared, we need to use the chain rule. So first we're going to take the derivative with respect to y. So we get 6y times now the derivative of y with respect to x, dy dx. And that equals derivative of 6 is just 0. So now we need to solve for dy. All right, so let's do that. So we're going to move everything over to the right-hand side of the equal sign. So I'm going to replace the dy with y prime. All right. Okay, so it looks good. But it would be nicer if we can write everything in terms of x. So this is where we can now solve for y in terms of x from the equation. So let's do that. So we'll do that over on the right here. 5x cubed plus 3y squared equals 6. We got 3y squared equals 6 minus 5y cubed. Y squared equals 6 minus 5y cubed over 3. Finally, y equals plus or minus 6 minus 5y cubed over 3. And we can plug that in there. We don't, it depends how whoever's marking it wants a solution. So we actually do have a common factor of 3. Oh, let's erase that, between the 15 and the 6. So why don't we factor that out? X squared over, brackets around that, over plus or minus the square root of 6 minus 5x cubed all over 3. It's not real pretty, but it's probably a lot easier to find the derivative of y this way than rewriting it and taking the derivative of this mess here. All right, so let's look at the next question. All right, we need to find the derivative using implicit differentiation of x squared y plus x equals 3x. So again, let's take the derivative across the equation, so left side and right side with respect to x. So we got 2xy plus x squared times y prime, so we get to use the product rule, plus 1 equals 3. Now we're going to solve for y prime. So let's do that. Bring everything over to the right-hand side. That 3 minus 1 is 2. Divide all that by by x squared, and we have a y in there. So let's solve for y from our equation. Let's just do that over on this side. All right, pick another color to do that in. All right, so x squared y plus x equals 3x. Let's solve for y. So we're going to bring everything over to the right-hand side. It's actually 2x over x squared. So y equals 2 over x. And we're going to take that and plug that back in here. And what do we get? We get 2 minus 2x times 2 over x all over x squared. That's pretty easy to simplify. We cancel out the x's. And we end up with 2 minus 4 over, running out of room. 2 minus 4 over x squared, or negative 2 over x squared. And of course, this is provided x does not equal to 0. Good. Okay. All right, let's try this one. So C, y to the negative 3 plus 2x squared equals 1. All right, so let's take the derivative. Use implicit differentiation. So negative 3y to the negative 4 times y prime plus 4x equals 0. All right, let's solve for the y prime. Okay, so negative 3 y to the negative 4 y prime equals negative 4x. Y prime equals negative 4x over negative 3 y to the negative 4. Actually, we can write that as 4 over 3x y to the power 4. Again, we need to solve for y, so we're going to do that from the equation. Let's pick another color to do that with. Okay, so we're going to solve for y. Y to the negative 3 equals 1 minus 2x squared. This y to the negative 3 is actually 1 over y cubed. Okay, so let's cross multiply and bring the y into the numerator. Now we need to take the cubed root of both sides. And this is our y. We're going to take that and plug it in here. And let's see what we end up with. Equals 4 over 3 times x times y, let's see, cubed root of 1 over 1 minus 2x squared, all raised to the power 4. We can clean this up and make it a little neater. 4 over 3 times x, 1 over 1 minus 2x squared raised to the power 4 over 3. And this is our y prime. Great. Okay, looks like we have one more. Okay. Okay, so let's try this one. Okay, let's take the derivative right across the equation. So a half x raised to the power negative 2 minus 2 times a half y to the negative 1/2 times y prime equals 0. Okay, let's solve for y prime. So we're going to bring everything over to the right-hand side except the y prime. Y prime, our 2's cancel out. So we're left with negative y to the negative 1/2 equals negative 1/2 x to the negative 1/2. Y prime equals negative 1/2 x to the negative 1/2 divided by y to the negative 1/2. So let's clean that up. Negative 1/2, yeah, root y over root x. And let's solve for square root of y. We're going to do that from the equation up here. Let's pick our green to do that. We're going to solve for the square root of y. And what do we get? we get negative 2 square root of y equals negative 1 minus the square root of x. Square root of y equals negative 1 minus square root of x over negative 2, or 1 plus square root of x over 2. All right, so now we can plug that into our y prime, and a bit more space to do that. We end up with y prime equals negative 1/2 times 1 plus square root of x over 2 times the square root of x. Good. All right, so we've used implicit differentiation to find y prime in each of these cases. So this brings us to the end of our session today. If you have any questions, send us a message at info@raisemymarks.com or give us a call, day or evening. And we look forward to hearing from you and helping you. Right, thank you for watching, and we'll see you soon.